Hello there, this session's notes are on fractional equations. So the essential question we're answering is how can I solve equations with fractional coefficients? And I mean, you can go through and solve the equations with fractional coefficients just like you would any equations, but we are in this lesson going to show you how to kind of get rid of the fractions in the process of solving, or just to make the solving a little bit easier. So you want to make sure you have the note test template out with this heading. So just as a warm-up on this one, we want to go through the steps of solving an equation, and we'll keep this one without variable coefficients till we deal with that, or fractional coefficients till we deal with that. And so we've got groupings on both sides. We know we want to eliminate those groupings in that first step. Be careful with that minus sign on the right. That is minusing or subtracting this whole term. So best idea to change that subtraction before you distribute. So on the left-hand side, we get 4a plus 8. On the right-hand side, 14 plus negative 6. And then plus a positive 4a. Again, watching that you've distributed that negative to both pieces. We have like terms on the right. We have 14 and negative 6. And so we end up with 4a plus 8 is equal to 8 plus 4a. Now you could continue to go through the solving process, but hopefully recognizing that what we have is the identity, that we have the same thing on both sides. And so that is one of your special solutions. That's going to be all real numbers. So taking a look at example 1, we're going to go over to the right and kind of outline the steps. The first thing we want to do is consider the fractions, and of the fractions that appear in the equation, we want to find the least common denominator. So, or at least a common denominator, but the best thing to do is to find the least common denominator. So my thought process on this, so I'm just kind of thinking about what can I multiply 7 and 3 by? What would be their least common denominator? And their least common denominator is 21. So my LCD is 21. So this is just kind of what I'm thinking about. You don't have to actually write this down every time. This is not work that you need to show us, but you do want to be thinking about it. And so then I'm going to use a transformation with an MLE to just multiply everything through by that 21. So I'm going to just show that I'm multiplying every term by 21, by that least common denominator. And then what happens there, if you do that, these cancel. Again, you could use your calculator, but you'll see me using the kind of fraction canceling. I'm kind of frenemies with fractions here. We don't love them, but we try to get along. And so we end up getting 3x plus, and here we cancel, and plus 7x is equal to 210. And so multiplying through by that LCD gets rid of the fractions. So we can say that step 2, to multiply each term by the LCD. And then you're just doing step 3, solve for x, and of course that actually is sometimes more than one step. And we go through our steps for solving the equations. So we have like terms to combine, and that gives us 10x is equal to 210. And then we can divide both sides by 10 or multiply both sides by 1/10, and that is going to give us x is equal to 21. Now you do want to think through a check. It's not like we're just eliminating the check, but you definitely want to think through it. So if I would do my check here, I've got my original equation, and I'm going to plug in my 21 for x, and 21/7 gives me 3, and 21/3 gives me 7, and so I get 10 is equal to 10, and so I know that my solution is in fact 21 because I got a match. So in the next example, again, thinking through the least common denominator to get rid of those fractions, we're looking at a common denominator between 5, 2, and 20. Now that least common denominator is 20. So that means we want to multiply every term in the equation by 20. So let's take a look at that. So we want to say 20 times 3a over 5 minus 20 times a over 2 equals 20 times 1/20. You can show that with parentheses like I did on the other side there. And kind of going through that fraction work again, you could use a calculator for this, but I like to just kind of show that it's not totally unfriendly to deal with the fractions because we can cancel. So 5 goes into 5 once and into 20 4 times. And so we're kind of multiplying the 4 times the 30 there, or 4 times 3 there, which gives us 12a minus, and then here we can say 2 goes into 2 once and into 20 10 times, and 10 times the a would give us 10a, and then 20 goes into 20 once and into 20 once, and we end up with just 1 on the right hand side. We can combine our like terms of 12a minus 10a, and that is going to give us 2a is equal to 1. And then isolating the variable, you're either dividing both sides by 2 or multiplying both sides by 1/2, and we get a is equal to 1/2. And so we're hoping that's our solution. Again, we should always check. So I'm going to go ahead and rewrite my equation to do that check. And when you do plug that in, you can use your calculator if that gets a little ugly for you, but you want to check that you get the same thing on both sides, and we do. Get 1/20 on both sides, so a is in fact equal to 1/2. So in example 2 here, we want to look at finding the least common denominator of 3 and 5. So thinking through that, and go ahead and pause the video, decide what it is, and put it in. Okay, the least common denominator there between 3 and 5 is 15. And so we want to multiply every term by 15. So we're going to multiply 15 times x over 3 minus 15 times x plus 2 over 5, and don't let that fraction worry you, and then 15 times 2. So 15 times every term in the equation. So again, that's just a transformation of MLE. And then let's deal with our fractions here. 3 goes into 3 once and into 15 5 times, so we can do a little canceling there. We end up with 5x minus 5 goes into 5 once and into 15 3 times. And so we can do a little canceling here. We're going to distribute, but you need to be careful. Be careful because that minus is in front. So we're really distributing a -3. We don't want to miss subtracting both pieces. So subtracting the whole term, we've got to show that -3. So I'll change that, and that becomes -3x plus a -6. And then on the other side equals 30. So again, just watching when that subtraction comes before something that's going to be distributed. And we do have like terms on the left, so we have 5x and -3x, so we're going to combine those like terms. That's going to give us 2x plus -6 is equal to 30. We want to get our constants to one side and our variables to the other. So I'm going to add 6 to both sides. To constant, cancel that out right there. That gives me 2x is equal to 36. And then just to finish up, I've got to isolate the variable by dividing by 2. And x is equal to 18. So for this next one, I'd love for you to pause the video and then think through your LCD and then go ahead and multiply through and just try this one on your own and then restart the video and see what you get. So see if you got the same thing that we got. So again, pause the video, try it on your own, and then restart. So hopefully you paused and got your solution. And then we'll check and you can see if you did this in the same way I do, or if you got the same solution. Hopefully you got the same solution, even if you didn't do it quite in the same way. So let's take a look at this. My LCD, my thought process is that the least common denominator, or the least common multiple of 3 and 4, is 12. So I'm multiplying every term by 12. That's going to give me 24n plus, here I've got canceling, 3 goes into 3 once and into 12 4 times, so that's 4n. And on the right hand side of the equal sign, 4 goes into 4 once and into 12 3 times, so that's 3n, plus the 12 times 5 is 60. Now I have like terms on the left. I've got 24n and 4n. So that gives me 28n is equal to 3n plus 60. And I want to get my variables all to one side, or variable terms all to one side. So I'm going to subtract 3n, or add negative 3n to both sides. Canceling there on the right. That gives me 25n is equal to 60. And I'm going to divide both sides by 25 to isolate that variable, isolate the n, get it by itself. And that is going to give me 12/5 reduced, just kind of reducing that fraction. And I am going to leave it in fraction form. If you'd rather put it as a decimal, you certainly may, but I'm going to leave it in fraction form. Please make sure you bring all your questions to your teachers, and we'll see you on the next video.